let's deal with the idea of the limit definition of a derivative. When it comes to limit definition of derivative, the questions would mainly be concerned with calculating the tangent and calculating velocity. And the limit definition of derivative is f of x, f dash of x, which is also the derivative of the function of x at number a, can be defined as limit h tends to 0, f of a plus h minus f of a by h. In this sense, basically, we just need to figure out what is the function and find the limit for it. Let's look at an example for it to make more sense. Consider the question that says, find the equation for the tangent line to the hyperbola y is equal to 3 by x at the point 3, 1. Now, when it comes to the limit definition of derivative, ask yourselves two questions. What is the function here? What is f of x? In this case, f of x is 3 by x. And what is a here? As they have given, a is the input that a function will be taking. Now, most likely, a would be the only value given in the function. In this case, it's 3, 1. And as you can see, we are just taking x values. So here we're going to be taking the value 3. Now, we'll plug these 2 and 4s in the formulas and solve it. So this will look like following, where I will place I have first put the input values of 3 everywhere, and then I'll put the function, which is 3 by x. So instead of x, I'll put the given values 3 plus h in this case, and 3 by 3, which turns to 1 in this case. Now, while it might seem that it doesn't lead to anything, carry out as much simplification as possible. In this case, the 3 and the 3 cancel out, and we end up with a negative h. The negative h and the h cancel out, and then we're left with negative 1 by 3 plus h, which becomes negative 1 by 3, which is also our answer. Another question that would turn up would be, in terms of velocity. As it might come forward, the velocity is actually the derivative of distance with reference to time. So in these questions, our f of x in this case would be the value of time, and the function would be the way distance has been explained. When it comes to velocity, most frequently distance has the formula of 4.9 t squared. If you look at the physics, 4.9 is technically acceleration due to gravity divided by 2 using the equations of motion. However, for the sake of calculus, we'll just need to put on this formula 4.9 t squared. So in this question, the f of x is 4.9 t squared, and the a here is 5 seconds. I will plug these into the formula and simplify the question. As you can see, this is the first equation, and we'll put in the function form 4.9 a plus h whole square, 4.9 a square. Then we'll simplify it, and finally we get to the conclusion of 9.8 a. So velocity at time a would be equivalent to 9.8 a. After we know this, we can move to the other part of the question, which is velocity after 5 seconds, which would be just using the formula given by the previous part of the question, which is 9.8 a. Instead of a, we would put in 5 seconds, which gives us 49 meters per second. For the second part, how fast is the ball traveling when it hits the ground? How fast refers to velocity. But here they are asking how fast is it traveling when it hits the ground. So we do not know at what point does it hit the ground. What we do know is that 4.9 t square is equal to distance. And the distance as given in the question is 450 meters. Calculating that, we get time is equal to 9.6 seconds. As you will see, when we carry out the square root of t square, the answer is positive, and we are not considering the negative answer because time cannot be negative in this context. Plugging the value of 9.6 into our original function 9.8 a, the value we get here is 94 meters.